Hello, good morning, sir. So today I'm going to solve 3x minus cosine of x minus 1 is equal to 0 if x sub 0 is equal to 1. So for this equation, there are four methods to find its roots. The first one is the method of successive substitution. So for step 1, I just show the equation in terms of x. So that would be transpose this to the right side and negative 1 to the right side, and then divided by 3 to cancel the 3 right here. So that would give us x equals to cosine of x plus 1 divided by 3. Now this equation will be our g of x. And to solve this, to find the root of the equation, we are going to iterate until our g of x is equal to x. So that's basically if our x here and our g of x is equal to each other. So for the first iteration, our x is equal to 1 since that is our condition right here. So for this, we're going to simply substitute 1 to this equation. So that would be x is equals to cosine of 1 plus 1 whole over 3. And that would give us 0.513434. The next thing you're going to do is the g of x, the one that we solve right here, will be our new value for x sub n. And then plug this value again to this equation, and that will be your new g of x. So in order to do this faster, we're going to use Excel. Since if you won't use Excel, you'll have to manually calculate it until our x sub n here and our g of x is equal to each other. So let's solve this using the help of Excel. So this is what we have right here. So for our first iteration, just put the number 1, and then for the g of x, we're going to write this formula that we have right here, which is cosine of b4, this one, plus 1 and divided by 3, which will give us the value that we solved earlier. Next thing you're going to do is you're going to go to the second row or your second iteration row, and then write in the cell equals to C4 since our x sub n here will be equals to our g of x. And next, you'll just simply drag that down. Just simply drag that down in order to apply the same formula for the next numbers, just like what I'm doing right here. And this one too, drag this down. So for the MOS method, we need to equate our x of n and g of x wherein they are equal with each other. So as you can see right here, in the 14th iteration, you can see that our x sub n and our g of x is already equal with each other. So that means this is the root of our equation. So let me just bold that and change its color. So using the MOS method, the root will be 0.607101648. For the next method, we have the bisection method. So for this method, unlike the MOS method, we are given this. Now, in order to solve this, you're going to need two numbers, which will be our a and our b. Now, these two numbers, when solving for their f of a and f of b, the answer must be opposite in sign. So the other one must be negative and the other must be positive. So we are going to solve this in terms of f of x. So your f of x will be this one. F of x is equal to 3x minus cosine of x minus 1. So for the first step, you're just going to check for its initial values. Just simply plug 0 to this equation, and you will get the value for f of a. So plugging 0 to the equation, you will get negative 2. And for f of b, plugging 1, since 1 is the value of b, you will get 1.45968. So our A is negative and our B is positive. The next you're going to solve is for the midpoint. And that would be our C. So for the midpoint, the formula is A plus B divided by 2. So 0 plus 1 over 2, that would be equal to 0.5. So we have our graph right here. We have our A and our B on the opposite sides and C at the midpoint. So as you can see, A is 0, B is 1, and C is 0.5. Now we need to solve for the f of C. For f of C, just simply plug in the value of C, which is 0.5, to the main equation. And that would give us negative 0.377586. So let me just quickly write it down. And our B right here is 1.459698. So in here, our C is negative, our A is positive, and our A is negative and our B is positive. So in order for the bisection method to work, you have to have a condition wherein our A and B is opposite in sign. So it could either be negative and positive, or it could be positive and negative, as long as they are opposite in signs or their signs are not the same. So if we just simply use A and C, it would not work because they have the same signs. Therefore, we will use the value of C and the B. So what will happen? Our C will be our new A, and our B will just stay the same. So we're going to write that over here. So for the first iteration, we have this, the one we solved earlier. For our second iteration, as I said, the C will be our new A. So the value of C is 0.5. So simply write 0.5 here, and B is the same, so it will be 1. Next, we're going to solve again for the midpoint. For the midpoint, we will still use the same formula. So that would be 0.5 plus 1 divided by 2. And that would give us 0.75. Now the value of C, we are going to plug it again to our f of x right here. So for f of C, that would be 3 times 0.75 minus cosine of x, 0.75 minus 1. And that would give us 0.518311. Now we are going to continue doing this until our value for f of z is equal to 0. So you're going to basically just iterate again and again until our f of c is equal to 0. So to do that faster, we're going to need the help of Excel. Now, how do you do that? So the first step, you're going to write how many iterations you plan to do. So you can just choose as many as you want. Just simply write the value of A and B right here. However, for the C, we are going to apply the formula to find the midpoint. And that would be A, as you can see here, A plus the B, which is H4, and divided by 2. Now we're going to solve for FC. So for FC, that would be, let me write the equation right here real quick so that we will not get confused. That would be 3x minus cosine of x minus 1. Oh. So for the f of c, we are going to write 3, as you can see here, times x. Since this is f of c, our x will be also c. Minus cosine of x, which is c again, minus 1. and then click check sign, and just simply drag it down like that to apply the formula to the lower sections. Now right here, we need to apply a condition since we cannot simply just drag down 0 to continue the table. We need to have a condition since we need to have our A and B opposite in signs. So for this one, since our C right here is negative, the condition for A will be if f of C, which is J4 right here, if f of C is less than 0, meaning it is negative, then our new A would be the value of C, and our A, if false, will still be the same. And since the value is true, our value for A right here will be the same as our C, which is 0.5. For B, we have the following condition. If our f of C is greater than 0, since our B is already a positive number right here, the value of B would be I4, which is C. However, if it is false, it will stay the same, which is H4. And since it is false, our value of B right here should be 1, which is correct. Now, for C, we don't have to apply a condition since the value of C will be the midpoint from 0.5 and 1. So just simply drag the equation applied in our first iteration. The same goes for the f of C. Now just simply drag that all the way down. Right here, for the bisection method, since we need to equate this to 0, or we need to find the root by iterating until f of C is equal to 0. After the 51st iteration, the f of C is already equal to 0. So that means this will be our root. However, if you're not using Excel, you can already see that this is already approaching 0 right over here, but it is not exactly 0. However, if you're going to stop at the 4th decimal places, you can see that it is equal to the 51st iteration also. So as long as it is approaching 0, that would be your root. Now, for the next method, we have the regular falsi method. So for this method, it is very similar to the bisection method. As you can see right here, we have our A and B should be opposite also in signs. However, they are different because the value of C is not the same. So for the bisection method, the C is equal to A plus B divided by 2, which is their midpoint. However, for this method, you're going to solve for C using this formula right here. So just simply plug the value of A and B, and we will have this -2 and 1.459698. Now you're going to solve for C after looking for the value of FA and FB. So that's A multiplied by F of B minus B multiplied by F of A divided by F of B minus F of A. Since F of A equals to 0, we have right here, and F of B is equal to 1.459698 minus B, which is 1, and F of A, which is -2, divided by F of B minus F of A. And that would give us 0.578088519. Now, since we already have the value of our C, we're going to solve for F of C by simply substituting this value to the main equation we have right here. So that would be 3 times C minus cosine times C minus 1. And that would give us negative 0.103255, which means that our value of C is negative. Now let's graph that for better understanding. So we have our A and B on the opposite sides of our line. And then we have here our C, which is 0.57805. Now, it is stated that our A and B should be opposite in signs. If we choose this and this to be our new A and B, then it would be wrong. So, for this scenario, we are going to choose a opposite sign, which is negative and positive, and that would be C and B. Now, this means that your C again would be your new A and your B would stay the same. So since we have our A and B right here, just simply write that in our new iteration number, which is our second iteration. We have right here our value of A will be 0.57, which is the previous value of C, and our B will stay the same. However, our C would not be the same since we are going to use this formula. By plugging in the values of A, F of A, B, and F of B, we will have 0.605958. And in order to get F of C, just simply plug this again to the main equation or to our F of X. So in our table here, I just simply copied what we solved from the previous iteration, the first iteration. As you can see, since our A is from the previous letter C, so our F of C will be also our F of A. And since we did not change the value of B, so our F of B will be the same as the one right here. Now we're going to continue doing this again and again until our F of C is equal to 0. Or if our F of C is approaching 0. Now to do this faster, we are going to use Excel. So as you can see right here, we have the following table. So just like what we did to the bisection method, just simply plug in the value of 0 and 1. However, for the column C, we're going to write the formula. So that would simply be our A, which is N4, multiplied by our F of B, which is this one, minus our B, which is Q4, multiplied by our F of A, which is, which is our B, is our O4, and multiplied by our F of A, which is Q4, and divided by F of B minus F of A. So next, our F of A, just like what we did with the bisection method, just simply plug in the values of A, which is this one, to the formula right here. 3x minus cosine of x minus 1. And that would give us negative 2. Now do the same for B and C. You can just simply copy this equation, like what I'm going to do right here. I'll just copy this. And then, I'm going to paste it for F of B. However, for F of B, you're going to change N4 to O4 since this is F of B and we need the value of B, not A. Just simply change that and you will have your F of B. The same goes for F of C, just like what we did to our F of A and F of B. So let me show that again. We're going to paste it, then change the numbers to C. and drag that down. So since the regular falsy method needs to show or needs to iterate until our f of c is equal to 0, that would be in our 12th iteration, which is right here. The last method would be the Newton-Raphson method. So unlike the other three, this method requires derivation. So this will be again the equation that we need to solve. 3x minus cosine of x minus 1 is equal to 0 at x sub 0 is equal to 1. Now the first thing we're going to do is to solve for function of x. So for function of x, that would simply be our equation right here. So let me write that one. That would be f of x is equal to 3x minus cosine of x minus 1. Now for our f prime of x sub n, that would be the derivative of our f of x. So that would be 3. So this cosine of x, so the derivative of cosine of x is negative sine x. And you multiply the negative to the negative sign here, that would be positive. So now that we have this, we're just going to substitute the value of 1, which is our x sub 0, to this equation and to this equation. So substituting 1 to f of x, that would be 3 times 1 minus cosine of 1 minus 1. That would give us 1.4597. And solving for f prime of x, that would be 3 plus sine of 1. And solving that would give us 3.84147. So now that we have our f of x, our f prime of x, and our x of n, we can solve for our xn plus 1. That would be xn plus 1 is equal to x of n, which is 1, our first value for x of n, that is x sub 0, which is 1. Subtract that with our f of x, which is 1.4597, and divided by f prime of x, which is 3.84147. That is equal to 0.62002. So that will be our value for x of n. Now we have our first iteration right here. So our f of x is equal to 1.4597, of f prime of x is equal to this one, and our x sub n plus 1 is equal to 0.62002. Now that we have this, we're going to plug that as our new value for x of n, which is right here. Now, how did I get these numbers? I just simply substituted the value 0.62002 again to our equation right here. So substituting this to this, that would give us this value, and substituting it again to our f prime of x, this one, that would give us this value. And I got this value by subtracting this one, that is 0.62002, subtract that with f of x, 3.58105, over, our f of x is 0.04618 divided by f prime of x, that is 3.58105. And that would give us 0.60712, which is our value right over here. Now we're just going to do this again and again until the value of our f of x is equal to 0 and our x sub n plus 1 is consistent. So you're going to iterate again and again until f of x is 0 or this one is consistent. Now to do this faster, we're going to need the help of Excel. So using Excel, we have this right here. So the iteration, to simply put the number of iterations you want, for x sub n, which is the initial value of 1, we're going to plug that in this column or in this cell. Now for f of x rather, we're just going to simply write the formula right here. That would be, let me just write that here. The formula would be 3x minus cosine of x minus 1. And for the formula for f prime of x, that would be 3 plus sine of x. So there you have it. For this part, we just simply put the equation 3 times our x, and that would be our value right here, and subtract it with cosine of x, the value right here, and subtract it with 1. For the equation right here, that would be equals 3 plus sine of w4, which is our x. And lastly, for the x sub n plus 1, just like the formula I wrote here, this formula, we are going to subtract x sub n, so that would be w4, subtract it with the fraction of x of 4, that is our f of x, over f prime of x, that is y4. So just simply drag this right here and drag it down and drag this down. Now for our x sub n right here, that would be the value of your answer right here. So just simply write equals z4 and you drag that down. Now you have a table that looks like this. Now as what I stated earlier, we're going to stop if our f of x is equal to 0 or if our x sub n plus 1 is consistent. So as you can see right here, we have a f of x that is equal to 0 right here. So therefore, the root of the equation is 0.6071. So as you can see right here, our roots are the same. That would be 0.6071. 0.6071, 0.6071, 0.6071, which is also the same right here and right here. This proves that our methods are correct. That would be all. Thank you.